Hi, Bruno. Welcome back to Airhacks FM.
Hey, Adam. Thanks for having me, bud.
The last time we spoke was Java 1. I remember. It was during lunch or was something, you remember? There was like a long table.
Yeah, we had a chat. We spoke about a lot of things. Let's not talk about politics again, because enough of politics. Let's just focus on technology.
We really about politics. I think Java, maybe Duke politics. This is what we did.
Is it copyleft or it's not copyleft?
The Duke is open source.
It is.
Yes, because of the other Bruno, right? Bruno Souza did it, I think, right? He was in charge of open sourcing all the Dukes. Very good.
Pretty much.
What happened? So you are involved still with Java, which is remarkable. And what's your title? You had always great title. The last time you were like a chief...
chief
Java specialist.
Maybe I'm not even chief at my home, man. That's my wife.
This is never the case, but it works. It's just like Azure, Java.
Oh no! Sorry. At Microsoft, I worked in DevRel. I worked in product management. I helped the Java engineering group at Microsoft build the OpenJDK from Microsoft. We did some libraries. We did AI libraries like semantic kernel for Java. We helped a lot with the adoption of our JDK inside the company and with tuning JVM workloads inside Microsoft. And then we helped customers on Azure using our JDK for tuning purposes. The few most recent projects that I worked on was one, the Azure Command Launcher for Java, and I think you're going to like this. And the second one is a Copilot SDK for Java. So the Azure Command Launcher for Java, we call it JAZ because, there is
cool
an
name.
Azure CLI. Yeah, because there is an Azure CLI called AZ. That's the Azure CLI. The command is AZ. So we thought, maybe JAZ, Java, AZ, JAZ.
Yeah.
And the reason for this tool is so that the tool will tune and configure the JVM for the user. So when they deploy a Java workload inside a container, they don't have to worry about setting heap size, selecting garbage collector, setting GC ratios, and whatnot. JAZ will do that for them based on a series of research and tests and benchmarks that we did inside Microsoft to find, what is the sweet spot that is not conservative enough, like the default ergonomics inside the hotspot JVM, but not aggressive enough to the point that the workload gets memory kill on Kubernetes. So we tried to maximize resource consumption to increase the chances of better performance and reduce resource waste on Kubernetes, especially Kubernetes. But it can also be used by VMs, as long as the VM is dedicated.
Because in order to make educated choices, JAZ has to know how I will deploy my container, right? He has to know upfront, my infrastructure. Okay, this is the number of CPUs and number of memory. So it has to be a part of the infrastructure, right?
JAZ runs on the production environment.
So it runs on production environment. Okay.
Yes. So for example, let's say you have a Docker file. And your Docker file today, you have the CMD line at the end of the Docker file that calls Java -jar your app. And the right thing to do is to always tune the JVM when running inside containers. Again, the ergonomics defaults are really bad for containers. So what we tell customers to do is replace the word Java with the word JAZ. So JAZ is the new JVM launcher for the Microsoft OpenJDK container images.
Is JAZ written in Java?
No, JAZ is written in Go.
Oh,
and and the reason for that is we want to make sure that the Go process is native, compiled to native, and it's super fast in startup because we want to do that calculation of memory settings and CPU and try to understand a little bit of what the application may do and also the version of Java that is being used because JAZ supports all the versions. It's not exclusive for one version or another. It supports from 8 to 25. And we have all the understanding of each version of Java has these sort of settings that we apply based on our research.
And everything is backed into JAZ. So you have like a small property files or database or whatever, which is ships with JAZ.
Yeah, we don't run a database, but yeah, all the calculation for the container environment happens inside JAZ. And then we trigger the actual Java launcher with the JVM tuning flags.
And it's also available with Azure App Services, all the services, or just Kubernetes?
Yeah, it's available for any environment. So the idea here is, back in the days when the Java folks at Sun Microsystems thought about default ergonomics, the scenario was different. There was no such thing as a dedicated environment. You have this massive server that you put in all these processes. You have your database, your web application, your Samba server, your file server, and then your Java application, right? So, and not only that, on the server side, on the client side, which Java also was very heavy in adoption, they wanted to make sure that Java would not eat all the resources in a desktop environment, in a client environment, because there are other processes running. There is Windows, there is your browser, there is your email client and whatnot. So that's why the default ergonomics of the JVM are very.
This was actually opposite design choice to Electron, right?
Yeah, sure. If that's how you want to put it.
Just fun.
I'll let the Electron folks talk to you later.
Yeah.
So at that back in the days, the environments were shared, and that's why the default ergonomics are conservative. But in the cloud world, we have virtualization and we have containers. And guess what? There's no more need to have big servers that are shared among different pieces of your system architecture. You can have a VM for this workload, a VM for that workload, a container for this workload, a container for that workload. And then for each workload, what you actually want to do is maximize resource usage within that dedicated environment for that particular workload. In performance conversations, the best performance of any system is the one that uses the most resources. Because that's about efficiency, right? Why having standby resources? Just use as much as you can, as much as you have dedicated. So that is the design principle of JAZ. We instead of trying to backport these changes to default ergonomics to old OpenJDKs, we thought, it's better to have a separate tool that tries to maximize resource utilization to increase the chances of better performance and reduce resource waste in production. And that is what JAZ does, basically.
Is it also available? I think no. Azure Functions, is it hidden, I guess, right? You know that?
So we are currently working with the Azure Functions team to enable JAZ as an option for customers to select, I want to use JAZ, right? But right now, it is available on the Microsoft build of OpenJDK container images. So developers can deploy Azure Functions with a custom container, and then within that environment, they can select JAZ manually to use. Same with App Service, same with AKS, Azure Container Apps, Azure VMs, you name it.
Okay, cool. Because Azure Functions, this is what interests me the most, because it's a true cloud, serverless. So I just but then it's hidden. I don't care what's inside. This was just I think you would use JAZ, but it's not visible, because if you use Azure Functions, I just say I would like to have Java 25 or whatever, and I get it, right? So it's not like I have to.
Yeah, we are working with the functions team. One option is to put a feature flag, right? So when you deploy functions, you can put a flag that says use the optimized JVM. And
but why not,
behind
right?
the scenes,
I mean, this is always use it, right? I mean,
yeah, exactly. Right now, customers have to tune the JVM on functions. Functions do not provide custom JVM tuning, so it is really up to customers to define that. So that's why we see the benefit for JAZ. On app service and other services, and by the way, you mentioned serverless functions being the true serverless. There are other services on Azure that you can have scaling down to 0 Azure Container Apps has that feature. AKS has that feature. App Service has something similar. So I think the approach for Azure Functions is not really that you can scale down to zero, is that you can have workloads that will be triggered based on events. That
It's not
is
like, for me, serverless is
true
just
benefit.
more than scale to zero. What I expect is, that I don't care about infrastructure at all. This is my point. And I wouldn't like to care about JDK. I would say what I usually doing with Azure Functions is just say, pick, the built-in Microsoft build of OpenJDK. This is what I learned after talking
Yep.
with you at the Java 1. And this is important for me because otherwise I will have to build the container. This will be my responsibility, and I don't like to be responsible, to build the container and the images. I would like to say, okay, hey, Azure, just run my JVM and do whatever you have to do. And scale to zero is just about costs. But what I care is about, not being in charge of infrastructure. What I'm usually are on premises. So this is why. I don't know whether serverless or not. I don't care. Maybe infrastructureless, right? So I don't care about any of the infrastructure. I would just like to implement my business logic.
Yeah, I think that is a great benefit. But what we do see from customers is the benefit on building functions, right, or function apps that are triggered by a series of events, and then easily connected. They can easily connect with the binders API of Azure Functions to different resources in the cloud.
Yeah.
So the customer doesn't have to do all the plumbing, right?
Yeah.
So the programming model of functions, you have the abstracted infrastructure behind the scenes, as you mentioned, but you have also this very rich programming model for designing function apps that is really beneficial to customers.
Yeah, of course. So you have two models. Is like the one where you can expose HTTP directly, and then event driven. But in both cases, I would see the option, that Microsoft installs for me the JVM and configures the JVM. I just ship Quarkus, which is actually the case right now because there is a Maven plugin. And if I configure the Maven plugin, it just installs the Azure function for me. So there's nothing to do for me, and this is what I like to see, right?
Yeah, exactly. Yeah, I agree. No, this is a good insight.
Maybe we should refresh the Azure infrastructure a bit. So we have Azure Functions. There were Azure Container Apps, Azure App Services. What I'm interested is more convenient ways to use serverless runtimes than Kubernetes. I would say Kubernetes is the most boring feature because I ran it for years on premises. If I go to the cloud, I would like to expect a little bit more convenience and not plumbing with. So there was Azure App Services, Azure Container Apps. No problem. If you are just the Java guys, then just brief refresher. How you can run Java on Azure in most convenient ways. I have Quarkus app, let's say, right? And I can run on Azure Functions. So I have already two options: on demand and premium. There are two different products almost, right?
Yeah, functions. Yeah, but again, keep in mind, functions is this specific programming model for binding to and triggers events, etc. Right? For the more traditional Java application, microservice application, think of Quarkus, Spring Boot, Micronaut, Drop Wizard, and Vertex, and so on. The best way to deploy those applications are primarily three. One is Azure App Service. You give a jar file and we run it, right? That's the best way. The second way is the container-based approach.
And Azure App Service is really, I give you the jar and you run it. No container image, is just a jar.
Just a jar.
Cool.
Yes. It has to be a fat jar, right? Without dependencies inside.
Yeah.
The second approach is through containers, and for that approach, we have two options. Realistically, two options: Azure Container Apps and Azure Kubernetes Service. Now, Azure Container Apps. Think of Azure Container Apps as a platform built on top of Azure Kubernetes Service. So you want some of the capabilities that Kubernetes gives people, like A/B deployment, canary deployment, versioning of images, etc. But you don't want to manage Kubernetes.
And I don't see much of YAML, hopefully.
No, you don't see much YAML or any at all. With Azure Container Apps.
This is already interesting.
You can use triggers. Let's say you update the image, and then the image on Azure Container Registry, and boom, it gets updated on Container Apps. Or you can use the Azure CLI to just trigger the redeployment. Or you can also use Bicep, which is the Microsoft Azure infrastructure as
language
approach,
which is actually cool. There is it was created by the Kubernetes inventor, and it is a true language, which I really appreciate.
It is,
if you compare it with Terraform, I would say it has for loops and if statements. So it is, and a Visual Studio Code plugin where you can actually work with it.
Yep. So that's Azure Container Apps. And then if you really want to go an extra level for more operational control, you can go with Azure Kubernetes Service. Now, here's the catch. Azure Kubernetes Service recently did release a new capability called Azure Kubernetes Service Automatic, which is something that is in between the full Kubernetes and Azure Container Apps. Like, I want the Azure Container Apps approach to some things, but I don't want to manage the whole thing of Kubernetes, but I want to have the option to, maybe. And that's where Automatic kicks in, and it kind of manages some resources for you automatically on Kubernetes.
Cool. So, and JAZ run everywhere and will run on Azure.
It runs everywhere, yes. So for folks who want to... let me see if I got a short link for this. I think I do. Yes, aka.ms/jazz. And jazz as in JAZ, not jazz with two Z's. It's not music. It's just a command line tool.
But
aka.ms/jazz. I like to say jazz can jazz up your JVM workloads inside containers.
Yeah, absolutely. Pretty cool. So, but and then you mentioned semantic kernel, which is it still active?
So, semantic kernel gave Microsoft lots of learnings and lessons, and we had customers using it. And recently, we published. Well, a couple of years ago, we released something called Microsoft Foundry, which is the Microsoft revamped AI platform, where all the AI services, AI models are bundled as part of that umbrella. And the teams have been working on a new agentic framework. Instead of having a framework, semantic kernel was trying to achieve something. How do I implement an agent? How do I build intelligent apps connected to AI models using these libraries? That's what semantic kernel was trying to achieve. But that was not the design for an agentic framework. So what the team decided to do, here's what we've learned with semantic kernel, but the world is moving to agentic. So they have started designing and implementing the Microsoft agentic framework. And the initial implementations are in .NET and Python. And now we have the teams starting to work into other languages, including Java.
Okay, and what will be the name of the because it's AI Foundry?
It's just Microsoft Agentic Framework.
Microsoft Agentic Framework. Okay.
Yeah.
And agentic means there is a for loop, right? Basically. So there's evaluation and everything runs, until the condition is met and you have the result, right?
Well, it's more than that, right? There is access to tools, definitions, to skills, to other agents and sub-agents and so on, instructions and prompts. The idea of triggering sub-agents with different models so you can actually compare the results and select the best result. There are lots of things that can be done when you go agentic way, because now you have these agents working for you and doing certain tasks, and then you have this orchestrator. So developing in an agentic approach really is about orchestrating the agents with the right instructions, the right approach, and how to evaluate results, and whether, as you said, to decide if the work is done or not.
What's interesting is First, it's very similar to microservices. So if you have experience with microservice architectures, you can see agents as dedicated microservices with specific tasks. But what's also cool is you can have not the orchestrator, but the smaller agents without any access to LLMs. This is the interesting part. You can have an agent which uses tools and whatever, but it doesn't need, an LLM to decide. So this is also interesting because what you mentioned, skills and tools, they are actually parsed and used by the agent framework, not by the LLM. So what happens behind the scenes is the agentic framework or a client or Claude or whatever you have, they are actually parsing these skills and they're creating, they are concatenating their strings and sending to LLM. This is what happens behind the scenes, right? So
yeah. I think there is a lot going on, right? We have this open claw thing where you have this farm of bots building their own social network. Yeah, Moltbot. Yeah. We have Mbabble from Rod Johnson building his framework for building agentic applications. There's a lot happening in the moment, and there's no clear answer to what is the right way of doing it. And that's the fun part. Everybody's exploring different ways of building these agentic systems because we can only find the right way once we extrapolate all the wrong ways. We exhaust all the wrong ways of doing it, right? Thomas Edison did not find the right way to do a light bulb. He just found 99 ways to find the wrong way. So that is quite where we are with agentic development.
But if you think about this, LLMs are unpredictable, more or less. I mean, there is some are predictable, but it is you cannot rely too much on them. And if the prompt becomes too complex or too long, and the context too big, the quality goes down. So this is truth. If you are building enterprise systems, it is a bad idea to have one app with complicated prompt and lots going on because really hard to debug the entire stuff. So I think this is the opposite to microservices. I think with LLMs, it's a very good idea to have smaller, simpler agents because you can see what they are doing, how they communicate with each other, And and in microservices, it is not necessary, actually, to have that because you can build a larger Java applications and you can still see what the application is doing because it's easier to debug. You can look inside what happens, but it's impossible to look inside LLM in the entire prompt. So this is actually a very good idea to have communication channels between and use open telemetry, whatever, to monitor, to debug what's going on between the agents.
Yeah, but so regarding unpredictability, I think the right word is deterministic ability.
This is what I search
right?
for.
Yeah. So here's the thing. One thing that we have started to come to an agreed shared conclusion is that agents should have specific tasks. I have this agent does this thing and this thing only.
At all.
Which is kind of like the Unix approach. grep does grep. LS does LS. If you want LS and grep to work together, put a pipe in between. Right?
It's how microservices were advertised back then, remember?
Well, to some degree.
Yes, they were.
That's a topic for a different podcast.
Yeah.
But I think when we start developing agents, we start building not a single application that does lots of things. We start building agents that do specific things.
Exactly.
Right. So what we attempt to do that is increase the determinism of their output based on the task that they are assigned for and the input that they get. Right. So you have to have some sanity check for the input. You have to very clear task. So you have to be very good in writing, defining what the task is. And then you have to have good sanity check for the output, right? So the agent doesn't do give hallucinations. But in between, the other element that is extremely important is what tools and capabilities the agent has access to. Because you don't want the agent to have open access to the internet to perform a task that doesn't involve access to the internet. Right? So how do we sandbox that agent? And there goes your microservice architecture. If I need this agent to do something with a database, and this agent needs to talk to tools capable LLM, well, the agent can talk. The application can talk to the agent, to the LLM, but it cannot navigate on the internet. Right? Doesn't have a tool for that. And the agent should not be able to write a Python script locally that can go and execute whatever it wants to do.
Yeah.
So there's a lot of work that goes into designing and developing those guardrails so the agent does one thing and one thing only and really, really well.
Yes.
And that is how we build agentic systems.
Exactly. And of course, you would like to have your operating system almost permissions that, one agent is not allowed to do anything just from the operating system perspective. And this is easier to understand if you build such a system, because you can trace the communication between agents. And so you have the entire protocol traceability, which is also important for business because you have an audit trail what happened behind the scenes, right?
Yeah, I agree. I think another element to consider here is model selection. And folks like to go, let's go with the best model and just use that model for all the agents. That's not what you want. You actually want to use, hey, this agent is good at this. And honestly, it's not a critical. It doesn't require too much thinking. So I'm going to use a cheaper model, a faster model, because that's what matters for that particular task. For these other tasks here, well, this agent needs reasoning. So let's go with a really good model that does really good reasoning.
Maybe even local model,
Yeah, exactly. So I think that is another element of building agentic systems, right? Doing the right selection of model, but also understanding when to use what model with what tools for what purpose. I think there is a lot of investments in agentic system orchestration, agentic system platforms, so that development teams can understand what the agents are doing, audit their input, audit their output, and what's happening behind the scenes, as many developers just don't know. They don't see, right?
Hey, I'm waiting now for AS. This would be the agent, Asia. It would select automatically the right LLM, They say, okay, I'm the agent. I would like to have this smaller. I'm there. Maybe less, because it will be better. LLM selector,
I'm glad you're not in marketing. That would be a very bad name.
We would deliver a keynote, on the Asia conference. Both we are announcing the AS.
But one thing that I thought recently was we need an agent EE application server.
Yeah, absolutely.
EE server.
Yeah, I mean, you're laughing about the application servers, but if you think about serverless, all my serverless ideas are stolen from application servers. For me, I know the entire serverless thing is an exploded application server. If you think about this,
yeah, true, yeah.
And
if you think
about all my talks, the last 20 years, I never cared about the vendors. I said I would like to focus on business logic. I don't care about your stuff. And serverless is this. It is actually Java EE on steroids. There's another marketing gag, you could say. Asia is Java EE on steroids, or J2E.
Did you know that there is actually a way to configure your Kubernetes environment so that the only thing that you deploy to Kubernetes is the jar file?
Yeah, for sure it is.
You can do that. Yeah, there is a way to do that. So and this is still in my to-do list to try it out, but you do need a custom Kubernetes operator to be able to do that. But all the pieces are there, just need to connect them, because the standard of container registries, I think it's called OCI, whatever. It's actually not for container images. It's actually for any artifact. It can be a jar file, a zip file. It doesn't have to be a container image. Which, by the way, a container image is a tar.gz file at the very end of the pipeline. So one way that you can have this nice deployment approach is, okay, I'm going to push this jar file to my artifact registry, and then I'm going to have this Kubernetes deployment set that pulls that artifact and deploys it. But I have to have the JVM installed at the Kubernetes node level, and then I can be able to run the JVM for that particular jar. So Kubernetes, I mean, I think you and I argued about this a long time ago, but Kubernetes is the polyglot implementation of the Java EE application server at the end of the day.
Yeah, with lots of YAML, which I don't like. This is why.
Yeah, we can joke about that, but there are lots of benefits of Kubernetes,
sure.
Way beyond.
But honestly, if
Java
I have the choice
server.
between Azure App Services and container apps or Kubernetes, and I would always pick Azure App Service or container apps and never Kubernetes.
Oh, absolutely.
This should be it's the same discussion. I was once, as a consulting, I had to implement something, and a guy was on a desk 2 meters away, and his laptop is run like crazy. So I mean, it was very loud because of cooling. And I asked him, "What are you actually doing here?" And he said, "Yeah, I'm compiling the Linux kernel." And I say, "Yeah, but how long it is going?" I say, "Yeah, 4 days from source, and this was like bootstrapping, whatever." I was like, "And why I'm doing this?" And he told me, "Yeah, in one point of time, I get the optimal operating system, whatever, and after 1 week, it was still not over." And I say, "Yeah, maybe." And this is so Kubernetes is also very flexible. But if I have container app or Azure function, whatever, I would just ship it to Azure and forget what I did, right? So this is I don't need this flexibility. And Kubernetes for me is more like I have a product and I have it already on premise, and it's very easy for me to ship it to Azure or to other clouds. So I have the abstraction, because Kubernetes on Azure are two clouds. So I have the Azure cloud plus the Kubernetes cloud. This is like running back then Spring in JBoss. I also had 2 dependency injection frameworks, and I was very flexible, but actually I only needed one, right?
Yeah, exactly. I think the other topic that is interesting on building agents, though, like all these CLI, like you have Gemini CLI, you have Codex CLI, Claude Code CLI, etc., Copilot CLI.
And we get as CLI soon.
What? No.
Agent
what are
as.
you talking about? Oh, Jesus. No.
A as.
No. So think what people can do with CLIs, both in their local environment, but also in a server, right? You have the CLI, which isn't an agent by itself, with access to lots of tools and the whole environment tools, right? All the Linux tools that are there. If you install wget, good luck. It will. If you install Python, good luck. The agent may write scripts, may connect to the internet, et cetera, et cetera. So
it does. Yeah.
So we have to go back to the sandboxing thing very carefully. But assuming that you have that in your checklist, one thing that I find really cool is the ACP and A2A protocols, where most of these CLIs implement these protocols. So you can actually have applications communicating with the CLI server, with these CLIs running in a server mode, in a headless mode, and then interacting with this agent. So your Java microservice doesn't have to use LangChain4j, doesn't have to use Mbabel or these or that framework, or even the Microsoft Agentic framework. They don't have to. They could just talk to the CLI that is running on the server next to it, and then the CLI does all the thinking and tooling and working, and then your application just gets the response from it, right? But there are lots of things that you may want to do. You may want to listen to events. You may want to listen to, when the session is idle, when the session is connected, when there is a response, when there is a usage metrics, what's going on during that CLI agent session. So for that particular scenario, for that particular architecture that I just drew here, that's why Microsoft built the Copilot SDK, which is a API and SDK for building applications that communicate with the CLI and delegate agentic tasks to the CLI. And that is very powerful with what can be done without having to plumb a lot of agent control and flow and orchestration inside your actual application. Your application just communicates with the CLI, and the CLI does everything. So for folks interested in Copilot SDK for that kind of implementation, just Google for Copilot SDK. And if you're interested in the Java SDK, add Java into your search, and you're gonna get that result. But at the end of the day, it's another approach for building agentic systems.
And take a look at the implementation, because you asked a question recent AHEX TV, and I took a look at the source code. And it looks already really nice and modern Java. So kudos to you or whoever wrote the example. So it looks nice with the Copilot SDK example, what I saw. But before we start with A2A, because it's also a fascinating topic, back to your J2E deployment to OCI, I had a chat. Are you aware of ongress or stackgress?
I am not.
There is a Mr. Alvaro Hernandez, huge Quarkus fan. Mm-hmm. And what he implemented is he used Quarkus as orchestrator, and he runs Postgres. He has a product. Think about that like a Postgres on Kubernetes, fully managed with backup and everything. And the entire orchestrator is implemented in Java with Quarkus with GraalVM. So the management and everything runs as Quarkus app, and it manages Kubernetes. And not only that, what he found out is that it is really hard to patch Postgres, and Postgres can have plugins. So what he implemented is a dynamic Docker images. So what I can do is he have custom registry implemented with Quarkus. So what he's able to do is to dynamically create Docker images or container images, OCI, for Postgres dynamically, which is crazy. And he can actually do whatever he likes. And he is on it. So if you check out the episode or just send him an email, he's very responsive, and he's a really nice guy, Java guy. It's already done. This was your idea, where we can use Kubernetes for more, and he does more now. He thinks about more than just using OCI for more than just launching container images. So he has you have to take a look at ongress and stackgress, and we have a couple of AHEX FM episodes with him, and he runs production databases. He's a Postgres committer, so he's really knowledgeable, and he runs the entire cloud on Quarkus basically and Kubernetes. And I think it could be really interesting to run on Asia as well, because because he has big clients, and
So what he built was basically an admin agent for Kubernetes.
An orchestrator with custom resources, and the orchestration logic is implemented in Quarkus. And the Quarkus is cross-compiled with GraalVM, so it starts really fast. So this is why I ask you whether JAZ is in Java, because he had also the problem that it has to start fast. And he decided to use GraalVM because it was more productive than Go, and uses Quarkus to manage the entire the custom resources. This is the logic which manages via the Kubernetes client the entire Postgres backups, upgrades of Postgres. So it's complete Postgres, open source Postgres cloud with optimization. But he is really knowledgeable. So he works, on Postgres level, on C code level to Java. So he is,
Yeah, I would love to take a look at it.
Alvaro Hernandez also. Mm-hmm.
So Adam, I'm curious to ask you: have you vibe coded an app already?
All the time, no kidding. But I hate the vibe coding because I do it actually all the time to see whether it works or not, or is not working. And what I found out is I found out this by accident in September last year. And a client asked me, is your circus with patterns and architectures still worth if you have a prompt? you write something and the app is done. What they are doing. With your ceremony. And I thought about this, and I got a complete different idea. So what I found out is whatever we did back then, you remember, product neutrality. So there is one API Java EE, JAX, and we don't care about REST Easy or Jersey. We just implement against API. And then we only use JDBC, never Oracle, JDBC, just JDBC and JMS. And I did code reviews, performed the reviews. And for me back then, I thought about this. And whether I wanted to deliver or even delivered talks, I have to review that about this was a great way to constrain developers for simplicity. For instance, I remember once we had to call to SAP. The API was not that nice, and there was JCA connector, and the JC connector was also not nice, but it was Javadoc, like 5 classes. If you take a look at the interfaces, you knew what happened. So you could call it, and it worked. You know what I mean? So this was a guidance. Now, and what I did is, with a little skills, I said, okay, hey, LLM, look, you're only allowed to use microprofile APIs, which are not the same story like 20 years old J2E APIs, just nicely named microprofile. Yeah. And if you take a look at the APIs, JAX and so forth, they are written in normative way. So this is must, not, and so forth. This is RFC 2119 or whatever. And I asked LLMs, hey, how well you understand this stuff? And they said, the cutoff was last year, but it doesn't matter because the API didn't change for 20 years, which is a good thing, right? And I say, interesting. And what I managed to do is, maybe with 100 lines of code, of skills, it generates now perfect, clean Quarkus applications without any hallucinations. Because it knows all the architectures, all the best practices from the past. What I only did is said, okay, don't go crazy with the unit test, because for unknown reasons, LLMs love, to create LLM unit tests. So they created 50 tests for something. So I just write 3. And I did this in this direction, and I showed to my clients, and this changed a lot, because what happens now, they say, this is like magic. This is unbelievable, because my prompt, my vibe prompts, or whatever we call this nowadays.
Your instructions.
In my, not instruction, the actual prompt look like, no kidding, create coffee BC. And BC stands for business components, and they know, of course, what BC is, because there is a ECB pattern from 1992. This is like Jimi Hendrix time. described
I was not born.
Described in all books and tutorials or whatever, and this is, and because LLMs are so data hungry, and what I did the entire time, I was too lazy. I focused completely on standards. Actually, whatever I did was the standards, and this is exactly what LLMs know, because all Java APIs and all the standards were crawlable. That's the thing, It was all the HTMLs were free forever. The Javadoc was free forever. And what I found out with my old patterns, I can generate perfect code. So this is that good that I didn't encounter any hallucinations so far. And I said, okay, maybe the LLMs are that good. And what I tried with Swift. So okay, come on, let's do some vibe coding with Swift. And this was complete different story. So there was far more the same model, but hallucinations invented and corrected. But it took maybe 5 times longer than Java. Java was one shot and was perfect. And then what I also found is from Tencent, a study, which thought that Java, the quality of Java output is 80% compared to Python 60%, JavaScript 60%. That means this because of Java nature and openness and crawlability, Java is actually well known by LLMs. And I tried different LLMs. I tried Mistral, I tried, the Claude, ChatGPT, and I have to say, it is game changer. So I don't know how to call it. What I do is I have a very brief prompts which look like domain-specific language, create business component and so forth, boundary control entity. and the LLMs know what I mean immediately, and they generate code which looks like my code. I review their code. So it's not like vibe coding. I say write Microsoft Office for me. It's not that. It's more like create a customer component, and they know what component means. They know all the patterns. And what I just did, my skills or Copilot instructions, or what I do in Copilot instructions since December last year. Copilot also understands skills. So what I do in Copilot case, in Visual Studio Code, I say, hey, in instructions, I just point to the skills, and this is what happened. And I start to publish the skills. There's a website called airails.dev. This is what I published 2 weeks ago. And I start to publish the skills because I got it. I showed this at Java user group meeting, and after 4 hours, I still got questions, and I said, okay, I have to publish somewhere. And this is actually the great history of Java, and this is a unique opportunity what we have right now, actually.
So when I was exploring custom, GitHub Copilot has the capability called custom instructions.
Yeah.
It also supports the skills specification.
Yeah.
The skills work well in the Copilot CLI. So once you have a skill loaded, you can do a slash and the name of the skill, or the LLM may call the skill regardless. But on Visual Studio Code and other IDEs, the Copilot plugin, they don't see skills yet, not the same way the Copilot CLI does.
I can give you now, it runs on my machine now.
You cannot call them directly with a slash command.
Not that. It's not necessary.
It's not. I know it's not. I'm trying to explain to you what some differences between what custom instructions are for GitHub Copilot and what skills are at the same time, because some projects can have both. So for GitHub Copilot, skills work as slash commands and as deliberately chosen by the LLM to run skills on Copilot CLI. On Visual Studio Code, you can only call skills can only be called if the LLM decides to use that skill. Period. You cannot do a slash command for that skill on Visual Studio Code chat. But you can do a slash command for prompts. So you can define your own prompt in a file, and then you can do a slash command for that particular prompt. Or you can have custom instructions based on file patterns or glob patterns. Or, this instruction here applies to all Java files. This instruction here applies to all XML files. This instruction here only applies to the POM XML file, and so on and so forth. The other cool capability for custom instructions, you can actually have a custom agent with specific deliberate persona definition for that particular agent. And then on the Visual Studio Code chat, you can select, I'm going to use this custom agent. And then it will load those instructions as part of the agent flow. So there are many ways to use prompts and instructions on any tool these days. I think the real question is when to use one format versus another. Right?
Can I give you my experience?
That is becoming more challenging. Yeah, go ahead.
So what usually happens, I have a minimal template with Quarkus with minimal set of APIs, which are always used for microservice. So like a brownfield, I have a Quarkus with end-to-end tests. I have already the JAX set up, the Assert-J set up. So there is a minimal setup. What I don't like, that the AI bootstraps everything is not necessary. So I have a minimal template, and this template is in GitHub, and there's a GitHub folder .github, and there are the custom instructions. I think this is the MD file, right? And skills is .github/skills, as I remember. This was the folder. And now the cool story is, what you can do is, you can tell in GitHub instructions, hey, look, the project is about Java BCE microprofile, and you can link in custom construction to skill, and then it works perfectly. I don't need the slash commands. I can have reusable skills with. I'm talking about a Visual Studio Code now, how it works right now. And before our chat, I had to upgrade to the recent Visual Studio Code, which is available right now. because it didn't work with Opus 4.6. So I had to upgrade this right now by hand. And I actually worked with that today, the entire day, exactly with this. And this works perfectly. And and I'm working right now on web components, exactly the same approach, that the skills are bound to a module. And this is the most convenient way for developers, because in this module, I only need one skill and the other skills are optional. Now, what's coolest, what I also implemented, is a review skill, for instance. And this doesn't work as a / command. But what happens in Visual Studio Code right now is, if I say review this architecture, this review triggers the skill and it also works perfectly. So this is feedback to you. So it already works right now. And I started to experiment with this, I think, in the mid of December, because there was an announcement from GitHub Copilot with the skills, and it works better than expected. So in November, it was like, last year was not that good. But since December or so, it is similar experience to Cloud Code, which I use the most, I would say.
So, I would like to see that. I'd like to see that that scenario that you described. Can you send a link right now? Let's discuss it live.
My link to the skills is not done yet, but the AI...
It's not published?
Yeah, it is. AI Rails dev, but there are lots of skills which are not published. AI Rails.dev. It's like a... And I could share screen with you, but...
No, send the link here in the chat, in the studio chat.
Yeah.
Let's take a
studio
look
chat.
at that.
If we have the chat, we will... The first time we are using the chat, I think, in the history of Airhacks. So we are now...
Here, Rails.dev.
AI Rails.
Oh, AI Rails.
Of course.
It's a horrible name. You're really bad at marketing.
This is a perfect name. What are you talking about?
Well, you don't know if it's AI Rails or Air Rails with one R.
This is cool. This is actually, which is fascinating. I can have multiple marketing departments working for me at the same time.
Okay. So let me see. So you have skill.md.
If you go to microprofile server, for instance, and click on the details, you go to the GitHub, and there is a skill. And if you put the skill to your
CLI.
What? Yeah, Java CLI, yeah. What I do, it is Java CLI skill would create Java 25 scripts for you. So I have lots of automations with pure Java without external dependencies. And static web and web components will be published soon. And this works in lots of projects, actually.
Oh, the Java CLI skill is weird. Why? So, it's cool.
Yeah.
But I gotta show you JBank.
Sure, but JBank is an invention of Crazy Max, right? And
but
Java CLI is nothing. It's just Java.
Yeah, but you can load Maven dependencies on it.
But I don't. The Java CLI, there are no dependencies. So since we talk about that, what happened, and this is just for you.
This is okay. Static web. Oh, I like the static web skill. This is good. This is a good one.
And Java CLI is also perfect because tomorrow I'm at a conference. We show 100 out of 1,500 Java snippets without any external dependencies. And what I showed you right now is the zero dependencies JavaScripts. And there are lots of scripts that are useful without any external dependencies. So the idea of the Java CLI is that you don't have Maven dependencies and how much you can achieve. So we have already a web server and whatever without any external dependencies. And why no external dependencies? Some of my projects are highly, healthcare, whatever. And if you have a dependency, we have to care about the dependency, security, whatever. And as you know me, and I say, okay, no dependencies, no documentation. I don't care about your audits, whatever, because we don't have any dependencies. And they are per default highly secure. And this is the idea.
So what is your take on why developers used to think about, let's not reinvent the wheel? What was the main core message behind that? Why people would prefer to not reinvent the wheel?
If you're thinking I'm trying to reinvent the wheel, I try to find the wheel in Java. This is what I try to do, right? So it's not like trying to reinvent something by myself rather than find the answer in Java, in JDK itself. And Java is more and more capable. And the script is about using just Java, what's inside, and not external libraries, for instance.
Yeah, but we could have a debate here, an interesting one that I see happening right now, which some developers and advocates of AI, they feel like, you know what, I'm not going to reuse libraries. I'm just going to ask my LLM to build the code.
Yes.
So I'm going to cut dependencies.
And I see this as an opportunity because if you understand the code and the code is testable, it could be better than external library, which is not that well maintained. It is one option to consider. No kidding right now. We have complete different possibilities than 5 years ago or 2 years ago.
So where do you see the industry going with open source? Do you think people will write more open source libraries for future LLM data set training? Or people will just give up writing new libraries because, you know what, why write this library myself? Or even, why publishing this library if the LLM can just write it by itself?
I mean, the next 1-2 years, what could happen is that, so what I try to do is to push still, if you build a larger system, of course, to have modules, but the modules is the most important thing. This is why I talk about boundary control entity, because in the BCE, what we had for 20 years, the idea of business component. And the business component is Java package, right? Vehicles, coffee, or whatever, with semantic meaning. And the cool story like now is, this scales well for LLMs. The most asked questions in conferences is whether this approach is also working for huge projects. The cool story, yes, because what I can do now to LLM, as a head LLM, extend please the coffee business component for me, and the LLM goes there and it knows what coffee is. So it only has to look at this component, not the entire project. So this is a good experience with that. So it means I can have as many components as I like, and the LLMs understand the semantic of the component without looking at the code too much, because Java is very expressive, verbose, which is very good for LLMs. And if I have to implement a trivial library like string empty or not empty, and I could absolutely ask LLM to generate this for me. And even better, I think if there is a public specification somewhere, then we are talking, right? So this is, I think this is the architecture decision in a project. Should we just pick the specification and implement it, a modern Java 25 zero-dependencies implementation of it, because then we are not depending on something else, and if it's well tested, could be one option. Why not? Take ownership of the stuff.
Yeah, no, I understand the idea, I understand the vision, but I feel like this can bring us to a point eventually in the future where nobody writes open source anymore.
This can happen.
Yeah, it is likely to happen.
Yeah, but with LLMs, we get different trouble anyway, right? I mean, this is, I mean, we have different possibilities, and we have to talk about it, right? So, I mean, And the next thing is, what I forgot to mention almost, I was not prepared for that part, or not thought about this part. If you have external dependencies in your project with LLMs, the LLMs don't understand what's inside. So they would try to decompile, the stubs and to find what's going on. But if you have nice code which is readable in your projects, they have no trouble to understand what's going on. They can refactor, they can upgrade. It's way easier now working with agents, with project with nice source code than external dependencies, because the external dependencies are not visible for the LLMs, except they try to decompile it, which will they do. If they won't find, a Java doc, they will use Java P, to do my observation, and try to understand the stubs, but it still is not the entire source code. There is no Java doc, so there's less semantic meaning.
I wonder if LLMs would be good at writing logging frameworks if logging frameworks have never been written before. What do you think?
Yeah. This is the general problem with LLM is this is like over time everything averages, right? So that's the problem. But I mean, over time. In the next 2 years, I'm still fine. And because of serverless, I don't need logging framework. I have to admit, this is the thing. If I go to cloud, I don't like to have the infrastructure. Whatever I built, 10 years ago, my serverless framework is system out println. No kidding. I have one interface wrapped to system out println. For Azure functions, good enough. There are no threats. It is fast enough. The logging aggregation happens in the cloud. So I don't need to segregate, log levels. I don't need JMX to switch whatever. I have nothing because I rely on the cloud. So my first decision is I don't care about infrastructure. I would like to have my cloud. If I'm in the cloud, I would like focus on business logic. If I do this, I don't care about external libraries because the entire infrastructure is not part of my problem.
Yeah, I think this will be a hot topic in the coming, I would say in the next year or so, when we see new, I can see people having less interest in reusing libraries when the LLMs can go ahead and just implement. But then I actually ask you, so why using microprofile and Quarkus and Java EE APIs when you can just ask the LLM to write you an HTTP server and implement you, an endpoint controller, a REST controller, whatever?
Mm-hmm. Because per accident, this is unique, I think, for Java with the platform. Because if I ground the LLMs against microprofile APIs, they don't hallucinate because they know it exactly, because the entire spec, if you read this, is almost mathematical language. They know exactly the structure because they never hallucinated.
So there's the value. Here's the value. The value of writing and publishing libraries is because they were not blindly written by LLMs and published. They were properly reviewed by humans who thought about the design.
Yeah.
Whether they used LLM or not, it's irrelevant. There was a deliberate decision by some human that thought, this is worth being reusable software.
Yeah, so, and the interesting part is the entire APIs we're talking about were implemented to be product neutral. So it means they were written in that way that it is possible. And what's also cool from the technical perspective, there was a clear separation between API and service provider interface. So if you take a look at JAX RS, there was Jakarta RS, whatever. So I can tell in a skill can tell the agent or skill or whatever, hey, only this import is allowed. Anything else is not allowed. If you have a custom library, you get so many variations, it's impossible. And forget about LLMs. I told the story multiple times on the podcast, but in one project, Python developers wanted to learn Quarkus. And they said, it is impossible because the tutorial is way too complex. I said, what do you mean? And they showed me the RESTful tutorial, and they told me, okay, look, this is reactive, non-reactive. There is a REST easy, not really easy, whatever. And they asked me how you are learning. And I say, to be honest, I never read this tutorial. It's like, what are you doing? I go to JAX RS. So the JAX RS spec, they have immediately, an example. It's just way easier for humans as well because there's only one path. And I don't care whether it's reactive or not reactive. This is my business logic, and reactive or not reactive comes with configuration. And per accident, this is perfect for LLMs as well.
So API design at the end of the day works as a guardrail for the LLM on how to write code, right?
Yes. And we are in the lucky situation that we got with Java API plus the spec, because this was the JCP story, There has to be the reference implementation, there has to be the API, and there has to be the spec. And the spec were always open. So you can point the LLM to the spec and it generates perfect code because there's no variations. But if I will point the LLM to Quarkus, what should generate? Which of the Quarkus variations should generate, and then it will immediately hallucinate. So this is actually the story. So I'm generating microprofile code which could run on Quarkus or Micronaut, which was actually the entire idea of Java and microprofile, but happens to be that the LLMs are like that because the specs were written in very strict way. And also cool, what I don't trust the LLMs yet. So if they generate something, I would like to fully understand. But they generate basically my patterns. So it looks like my code, so I can immediately spot, okay, this looks good, go. So this is also the reason why I would like to have high quality code. Otherwise, I wouldn't be interested in Java. They should generate bytecode. Who cares, right? I mean, why I need source code if they are perfect? I mean, they could generate bytecode and or machine code.
That is an interesting take. If LLMs could LLM write bytecode directly?
Yeah, it could. April the 1st, I did Hello World. I said LLMs are so good we don't need Java, and it worked actually.
Interesting.
I published a video about that.
I never
April
thought
the 1st.
about that. That's interesting.
But what I try, my approach is now not to be faster necessarily. What I try to do is to put as much semantic and business information to the components so that developers immediately understand, or not immediately, at least with some effort, of course, because they have read, package-info.java, right? This forgotten feature in Java. This is package-info.java is a way for Java
I use
packages.
that.
Mm-hmm. Yeah, I also use that. But I have to admit, in my books, I wrote about that, but sometimes I was too lazy and didn't happen.
But today
in some project,
right?
in some cases, late night, sometimes I forgot, to write the package info.
Yeah, but today it's so easy to do that. You just ask the LLM, hey, find all the classes in this package and document the package.
And this is what is forbidden my way. So LLMs love to do this. It's like LLM, you are not allowed to do this. What LLMs are doing, as a LLM, because the package is a business component. So I told in the skill to the LLM, write the intentions and background information of the component into the package info. And they write additional meaning. What was the component about in business perspective with links to Jira, specs, or whatever. So it's just perfect. And the cool story is now the software is better than before because now it is more maintainable for humans, but also for LLMs. So what I found out that if high quality software is good for both. And if you wouldn't have this, LLMs, if they would generate something, it could work, but after a few iterations, forget it completely. The semantic context is lost. So what we need, a tree-like structure with semantic meaning and additional business there. And what I'm thinking right now, the next step in a few months is I would experiment with annotations, custom annotations to put even more business meaning. Just annotations which are like additional Java doc because the LLMs love it. And I think the results will be even better. So I don't know whether you call it vibe coding what I'm doing, but I'm doing this a lot the entire time actually. And
this is very, I would say you're doing very agentic coding or agentic engineering because you have specific tasks. I mean, if a developer breaks down tasks into different skills, sure, you call it a skill. So folks are using this terminology just to give names to things. But at the end of the day, that is a particular task. And that's great. And I think that is what allows us to set those guardrails and those specific tasks with specific input and specific output and increase the rate of determinism of the work that the LLM is doing. So I think that this is very different from vibe coding. Vibe coding is, here's my prompt. Hey, agent, go figure it out. Here's like a 5-page markdown of a system that I want the LLM to implement. Boom, done. And I think that doesn't work at scale. But when you start breaking down into smaller tasks, skills, custom agents, and so on, you start actually building a software development team with agents.
Yeah, exactly. And because talking with you is always interesting, we have no time for A2A in Copilot, but we have to because this A2A, the reference implementation is Quarkus. I don't know whether you're aware of it. The Java A2A reference implementation is Quarkus. If you search for A2A SDK Java is Quarkus.
Yeah.
With index card and stuff like that, it's really highly interesting. And I would love to talk more deeply now. We have now the context, Java SDK Copilot, of course, now, because the mix, A2A Copilot, what I'm doing, so we have to sync soon. Are you at Java 1?
Let's do it. I'll be at Java 1, yes.
Yeah, I can show you. So at least we have a chat there, and before or after Java 1, another podcast for our listeners, just to chat about skills and external libraries, open source or whatever.
Awesome. This has been great, man. This was a great chat. I think we covered a lot of topics, and I would encourage folks to share, especially the second part of this podcast, because it was extremely valuable.
And maybe the last thought, cliffhanger for the next time, is what I do a lot as well. Actually, I think I had a chat with Red Hat developers back then, and they did the same because we are humans. They wrote the reference implementation first, and spec came afterwards. So, okay, now something is working, now let's write the spec, right? Because sometimes it works that way. And I do the same. So I implement, from my perspective, a minimal perfect code, and then ask the LLM, generate now this skill or whatever. And it generates the skill, but the abstraction is not good enough. So there are no examples or whatever. And say, hey, this was supposed to be actually a template for other projects. Just remove whatever project specific. And then I iterated on it. And this could be a template for open source projects. Because what we get then, right? We get an API. And we could use LLM to have multiple implementation of the API with different characteristics. And if you have that, there's semantic meaning, which is highly reusable for LLMs. So what may happen is that in Java, instead of using jars as dependencies, I could use open source code as dependency. Why we need the jar? This is maybe what we have to think about. So I'm experimenting already with GitHub modules, submodules, just to think about the source code reuse over jar reuse. This could be open source. I don't care, but it has to be source code actually.
Well, there are. I think there were tools that people could. I think there are tools. I heard this. There are tools that can help you shrink the dependencies that you have in your Maven project to only the pieces of the libraries that your code is actually touching.
Yeah.
Of course, this may not work for many libraries, especially the ones that use reflection a lot.
And licensing issues, and stuff.
Well, licensing, assuming license is permissive.
Yeah.
But there are tools there that can shrink your dependencies. This is what GraalVM does when it builds a native image. But not shrinking
dependencies. I mean, the LLM
what I'm telling, I know. What I'm saying is narrowing the quantity of code from dependencies. What you're proposing is, I'm going to just point the LLM to look at the source code of these libraries and only re-implement the pieces that matter for my application. The downside of that is that you are paying a very high price in terms of money and energy consumption. If people are concerned about sustainability, people are triggering LLMs, which are very costly to data centers infrastructure, to redo what has been already done. And I'm not sure if that will sustain long term. From cost perspective, from sustainability perspective, the reason we write software is to automate something so we don't have to write that software again and again and again. So if we are using LLMs to rewrite software all the time, that's weird. I would reflect on that.
I was not clear in this thing. So if you go to my GitHub account, maybe you will find I cloned recently a JSON API. And are you aware actually of org.json Java? I found it by accident. Org.json Java is maybe the oldest JSON API. It is the API, it is the reference implementation for JavaScript, and there's also reference implementation for Java, and the objects are called org.json. It is ancient. The cool story is this API has maybe 20 classes without external dependencies, self-contained. And in my recent projects, I had everything on board, no dependencies. Everything was in Java 25, but not JSON. So what I only missed is JSON. And this is not good because, I don't need Maven, I don't need nothing. And just because of the stupid JSON, I had, to introduce Maven or whatever just to have a JSON. And I thought, okay, let's take a look. And I was able to clone the library and reduce it to 5 classes. And I have complete reference implementation with the 5 classes. What I do right now is I copy over these 5 classes without changing the package, nothing to my project. And LLM immediately understands what's going on because the classes have JavaDoc and whatever and works perfectly. Whereby, if I will add a jar with the dependency, the LLMs won't see the source code. There is no context and they won't understand what's going on and they will try to decompile the dependencies in order to know what's going on. You know what I mean? So for these 5 classes works. I'm also experimenting. It's not like what you're talking here is no enterprise best practices. Shrink down external libraries to 5 classes and try to introduce it. Just telling you that this worked surprisingly well, just as an idea. And this is my approach for my internal project, for my internal tools. It works perfectly. And
I'd love to see an article, if you have an article or a video of that.
Conference talks. I was at JFocus was the first one. Java one will be the next one. I will talk about that, but maybe not in this depth. I will just show the show with the components, whatever.
Okay, you show me a Java one.
And I will have my laptop with me, and I can show you all my private project with Java 1. There's no problem. But the talk will be more, focused on enterprise.
Okay. Yeah, let's look into that when we meet at Java 1 for sure.
Perfect.
I'm curious.
Thank you a lot. And I have to reinvite you back with Copilot SDK and whatever, because this was actually, I wanted to talk about that. And instead we talk about 20 years old Java E again. This is also a little bit dangerous with me.
Yeah, let's save a time for Copilot CLI and Copilot SDK. I think you're gonna like. I think folks who are using GitHub a lot will like a lot that experience.
Perfect. Thank you a lot. Where people can find you on the social medias?
Well, I'm on LinkedIn, Bruno Borges, and I'm on Twitter. I'm on Blue Sky. I'm on Substack. I'm on Reddit.
Wow.
And I'm on Digg. Oh, by the way, I'd like to invite you, Adam, to the website digg.com, digg.com.
This is the old one, right?
No. This is an old website that the founders restarted.
Yeah, exactly.
And it used to be like Reddit, right? Mm-hmm. And I created a community there called Into Java. Mm-hmm. So digg.com/Into Java.
Into Java.
So yeah, it's brand new, not few members, but hey, all communities start that like that.
Yeah, thank you. Digg into Java, right? The Duke is already working. Mm-hmm.
Exactly.
Okay. To all is digg.com/into Java. Very good. Thank you a lot, and see you soon.
Adam, thank you so much. See you soon. Bye.